today I'm going to demonstrate how to properly use an Oxy-Fuel cutting torch. First thing we want to talk about, of course, is lab safety. These particular safety glasses have a shade 5 lens in them, and that's the suggested shade for Oxy-Fuel cutting and welding. That's going to allow you to be able to see the cones, the kerf, and the flames all as you should without just seeing a big bright light, seeing spots when you're done. Next item, of course, is gloves. These are my cutting and welding gloves. Any type of glove, as long as it's leather based, most of the time will work. They come in any shape, color, size, it doesn't matter. As long as you have some type of glove to protect your hands from the sparks and spatter and burns. Now, let's move over here to our tanks. This particular tank is acetylene. That's our fuel gas in our Oxy-Fuel systems. This has a single-seated valve and should be open a quarter to a half a turn. That's a safety feature. Let's say we're cutting and we drop something hot or sharp onto our hoses, and we have an open flame shooting out of our hose. With this valve, we can get over here and just one quick, swift turn, have the fuel cut off. That's going to extinguish the flame and keep it from sucking back into the tank and causing a large explosion. Now, next, of course, we have our oxygen tank. This particular tank has a double-seated valve. Should be opened all the way, or it's going to leak at the top of the hand wheel. Now, some of you might have some tanks at home, say on a farm, in a shop, in a garage, whatever. And after a week or so, you come back and your tanks are empty. You've checked all your fittings, you make sure your valves are shut off, whatnot. Chances are you left your tanks on and you did not have your oxygen all the way open and it leaked out the entire bottle out the top of the hand wheel. Now, let's talk a little bit about working pressure. Our working pressure, of course, is the pressure that's coming out the end of the torch as it's being used. This adjusting screw on the front of our regulator is what determines the working pressure. To properly set working pressure, we want to crack open our valve and adjust our adjusting screw to the desired pressure. Now, that pressure for acetylene is 7 pounds per square inch. Oxygen will be 45 pounds per square inch. Now, once we've got our pressure set correctly, and we want to get over here, first thing we want to do is make sure we have a clean tip. That's the number one thing to produce a quality cut in Oxy-Fuel cutting, is to have a clean tip. To make these tip cleaners, just for that, it's a little round file used to clean out the orifices in the end of our torches. Now, there's 6 preheat flames that come out the end of this torch and 1 center orifice. That center orifice is oxygen. Those 6 flames, or 6 holes, should be cleaned just as well as the center orifice. You want to take and just run that file in and out a few times. Make sure there's no sparks and spatter stuck to the end of that tip and in those holes. Once we know we've got a clean tip, we want to make sure we have all our safety attire on, put our gloves on and our shade 5 cutting glasses. And we want to take what we call a striker. Some people call them flint lighters. There's a piece of flint inside here that rakes across a round file, produces a spark. Now, we want to open our acetylene valve, just crack it lightly, strike it. Now, a lot of people want to take and turn it wide open. Hotter the better. Well, that's not correct. We want to make sure to back it down. We want to barely hear it and still see smoke, because there are proper pressures that need to come out of here to produce a neutral flame. Now we want to take and crack our oxygen jet open to where that cone, there's a center cone in there that just goes away. Now we have individual cones, which is our preheat flames. We want to take and push our oxygen jet and adjust it. Down here is exactly what we want. Now that's a neutral flame, roughly 5,900 degrees. And now, if you can see it, there's 2 little lines that go through here when I introduce this oxygen jet. That's our oxygen going out there to produce our cut. Those lines need to run parallel with each other and be straight. If we have one that's straight and one that tapers off, that's what our cut's going to look at. That's going to decrease the quality of our cut and of course decrease production times and whatnot. Once we know we have a proper neutral flame, we're going to come over here to our plate. Got a piece of 1/2 inch plate. It's mild steel. One thing a lot of people don't understand is you cannot cut stainless steel and aluminum with a cutting tool. Mild steel is really about the only thing you're allowed to cut. Now we're going to get down here. Those of you that are right-handed, you're going to hold the torch in your right hand, cup it with your left, and sweep it to the left. You're going to start right and go left. Those of you left-handed, you're going to hold the torch in your left hand, cup it with your right, sweep from left to right. We want to get down here. You never want to put your elbow down. That's going to limit your mobility. You're going to be able to do this, make an arch. That's about it. We want to rest the side of our hand, or pinky, or wrist, whatever you like. Something that's going to give you a little added versatility to your gutting. Now we're going to get down here. We're going to heat the metal to the kindling temperature. That's the melting point. When I see these fine sparks coming off of it, kind of like a sparkler, that's when we're going to know that it's ready to cut. Once we know that, we're going to back our torch off the edge. We're going to push our oxygen jet. And we're going to start our cut. Now, once we've got our cut completed, we know we're done, we're going to extinguish this flame. We're going to start with the fuel, we're going to take our acetylene valve and shut it off. Now, a lot of people forget, your flame's out, okay? They're going to put the torch down. Well, we still have oxygen running out the end of this torch. We want to make sure that we shut this oxygen valve off as well. One thing we want to remember is these valves have these small O-rings in them. That's what seats them off. To make sure they're off. We don't want to crank these down excessive. That's going to crimp or pinch and possibly even tear our O-rings, cause the torch to leak, lose all your gas, and of course a big safety problem when we have acetylene leaking into the shop. Like I said, once we're finished, we're going to come over here, we're going to take this acetylene tank, we're going to shut it off, do that quarter turn and be done. Oxygen, we're going to shut it off as well. Once we get those off, we're going to back our adjusting screws out. That's going to keep the pressure off of our diaphragm inside there. That's going to increase the life of our regulators, because there's a rubber diaphragm in there. And if we have a full tank of oxygen, there's roughly 2,200 to 2,400 pounds per square inch of oxygen compressed inside that tank. And if we have this adjusting screw tightened all the way up, we got 2,400 pounds of pressure hitting the back of the tight diaphragm. That's going to either blow the diaphragm or stretch it, and it won't read correctly. You won't have the correct working pressure. It's going to fluctuate up and down because your diaphragm is loose. That's the reason we back these adjusting screws out. So there's absolutely no pressure pushing against that diaphragm when we open up these valves. Once we've done this, we just want them loose. We don't want them to shoot out just in case the diaphragm did blow. We don't want that adjusting screw to shoot out into somebody. Now we're gonna bleed our lines. That's just where we empty the lines from the regulator overnight, so in case something happens with fall on it, it can't produce a flame and possible explosion. We're just gonna push our valve down, empty the lines both ways, acetylene as well. Once we've done that, of course, coil them up nice and neat, so they're not trip hazards or whatnot. Now let's take a look at this cut. As you can see, nice straight lines. Our cut lines are straight up and down, that meaning I had my torch head straight or perpendicular with the plate. That's going to make our lines nice and straight, going to look a lot better. Main thing you want to remember, of course, with cutting, we want to be able to take one piece of plate, cut it, join it to another, little to no grinding. There's little slag on the back side of this. Most of it would chip right off. It's peeling off with gloves right now. Most of them will chip right off with a chipping hammer. We don't have to grind on it or whatnot. That's an increase in time that you're not making money. So that's going to conclude my demonstration for today. Thank you for watching.